Hello students, today we will discuss about the pesticides. Also we will discuss about the aquifers, the hydraulic gradient and the wastewater treatment. So let's start the class. Hello students, so we are discussing about the water pollution and control. So today our lecture is 20. So these are the objectives of today's class. So after this class, you can classify the pesticides. So today we will discuss about the pesticides. You can define the aquifers and hydraulic gradient. You can state the Darcy's law. You can know about the Darcy's law, and at last you can know the process of wastewater treatment, which is very important. These are the some of the recapitulation of previous class. In the previous class we have discussed about the alkalinity of water, the eutrophication, and also the biochemical effects of heavy metals. These are the topics that we have discussed. Okay, so this is a very quick review. This is a question. You have to fill in the blanks within the 10 seconds. And the question is, Itai disease is caused due to the presence of, here you have to write down your answer. So your time starts now. Okay, so your 10-second time is over. Now, yes, of course. Here is the answer. That is cadmium. In due to the presence of cadmium, Itai disease will cause. Okay. So these are the chemical parameters that we are discussing about, like pH, chemical oxygen demand, dissolved oxygen, BOD, total hardness, and last day we have discussed about the heavy metals and alkalinity. So this is the alkalinity. Actually, alkalinity is causing due to the presence of bicarbonate, carbonate, and OH minus. All of you now you know the matter. Okay, now this is the eutrophication. Very important. Okay, eutrophication, generally what will happen due to our activity, due to the water pollution, the amount of nutrients, the enrichment of nutrients will cause the eutrophication. Okay, while the in water the nutrients will enrich, that time what will happen, the algae, some of the phytoplanktons, their the growth of that plants will be rapid. So what will happen, while total water body will be covered by the plants, they will absorb the consume the water, dissolve oxygen. So thus the level of the dissolved oxygen will decrease, and which is very harmful for the aquatic lives, other aquatic lives. Okay, whatever we have. So this process is called by the eutrophication. So these are the some of the causes of eutrophication, like use of fertilizer, excessive fertilizer, detergent, wastewater, mixing of the wastewater into the water body. Okay, so these are the all causes of the eutrophication. Now we have discussed about the biochemical effects of heavy metals. Generally, you have in your syllabus, that is arsenic, cadmium, mercury, and lead, and all these the sources of all these heavy metals are generally the industry and factory. They are mixing to the water. Okay, so these are the some of the biochemical effects of mercury. Generally, with the heavy doses, we can have the kidney damage. We can have the respiratory failure. Okay, yeah, this is the biochemical effect of lead. If we consume lead, contaminated water, that time we will have this type of problems. Lead can inhibit the synthesis of hemoglobin. It can interfere with the normal development of children's brain. Now cadmium. So generally, with the presence of cadmium or cadmium contaminated water, if we consume, we can have this type of disease that is called itai. Earlier you have already told us. Mm, and cadmium is generally enter into our food chain through the seafood, through the organ meats. Okay, so we can have kidney disease, because as the excessive cadmium can be stored into our liver and kidney. Next is the biochemical effect of the arsenic. Generally arsenic 3 is more toxic than the arsenic 5, as what will happen, excuse me, these metals having the tendency to bind up with the sulfur atoms, and which we have in the enzymes, okay, which we have in the proteins. So while we are taking that arsenic 3, it can bind up with the enzyme, it can bind up with the proteins, and which will be very harmful. So these are the some pictures of the arsenic contaminated water. If we touch, our skin is exposed to the arsenic contaminated water, that time we can have this type of problems. Generally these are called by blackfoot disease. Okay, so these are the biochemical effects of the heavy metals. Now today we will discuss about the pesticides. Okay, so all we know that we are using the pesticides generally for destroying the unwanted life forms, but pesticides are very poisonous. Okay, so we have to use the limited amount of pesticides, otherwise it will excessive amount will discharge into the water, and that water will be polluted, and then if we consume that water, that will be very much harmful for us. Okay, so pesticides can be classified by the based on its use and chemical structure. Like insecticides, the pesticide which can kill the insects, that is insecticides. Okay, like some of the organophosphorus, carbamates are used generally as the insecticides. We have another classification, that is fungicides. Fungicides means fungus, it can kill the fungus. Okay, like dithiocarbamates, generally cupric salts, they are all using as a fungicides. Now rodenticides are actually they're killing the rodents, rat like animals. Okay, so warfare fairness will be used for as the rodenticides. Next is fumigants. Fumigants means whatever we are using pesticides as a fumes. So that is called fumigants, like aluminum zinc phosphate, okay, methyl bromide. So these are all examples of the fumigants. And herbicides all you know, that is biperidyls. They are using as the herbicide, and insect repellent, that is diethyl, DEET. Okay, so these are all the classifications of pesticides. Now control. So how we can control this pollution with which will take place with the help of the pesticides. First of all, we have to use the pesticides in very limited amount. Most water pollution does not come from the normal correct uses of pesticides. Okay, actually while we are using excessive amount, that time only water will get polluted. So pesticide use of pesticide and fertilizers with less potential for surface runoff or leaching. Next, what we can do, we can first taste our soil, otherwise test our soil to determine that actually the fertilizers, actually the pesticides are needed or not. That we have to first determine. Okay, and always we should calibrate our pesticide application devices to ensure that the correct doses is being applied. And second, and at last we have to prevent the pesticide spills or leaks from the application equipment. Very important. Okay, so these are the some of the control measurement which we can apply to prevent the water pollution by the pesticides. Okay, next topic is aquifers. What are the aquifers? Generally, aquifers are the saturated zone. This zone is called by the aquifers. This is the four layers of the groundwater. The this layer is called the bedrock. The bottom layer, after that bottom layer, the bedrock. After that, we have the saturated zone, then we have the unsaturated zone, and then the earth surface. Okay, so in between saturated zone and unsaturated zone, we have the water table. Okay, so this zone, the saturated groundwater level is called by the aquifers. Okay, so saturated means here in this level only the water molecules are there. Okay, and unsaturated zone, in the unsaturated zone we have water as well as air molecules. So so it is very obvious, from the saturated zone only we can get the groundwater. Okay, because for the unsaturated zone, what will happen, there are air gaps are there, so we cannot take out that water. So saturated, from the saturated zone only we can take out the water, and this is called by aquifers. Now next topic is hydraulic gradient. Hydraulic gradient, like this is again the the four layers of the groundwater, and from the earth surface we have digging, we have we dig two wells, A and B. Okay, and H1 is the height of the well from the surface, and B is the, and here HB is the height height of the well B. So hydraulic gradient is hydraulic gradient is HA minus HB divided by L. What is L? L is the distance between the two wells. Distance between these two wells. Okay. So that is equals to delta H by L. So this is called by hydraulic gradient. Understand? Hydraulic gradient. Okay, next, Darcy's law. According to the Darcy's law, we can know the what will be the flow rate of the water. So, according to this law, the flow rate of water, that if we consider it as a Q, so Q is proportional to the cross sectional area A multiplied with the hydraulic gradient, that is dH by dL. So Q equals to K into A dH by dL, where Q equals to, you all know, that is the flow rate of water. K equals to the proportionality constant, and it can also called by the hydraulic conductivity or coefficient of the permeability. And dH by dL is the hydraulic gradient. Okay, so according to the Darcy's law, the flow rate of water always proportional to the cross sectional area and to the hydraulic gradient. Now only this law can be valid if the flow will be streamlined and the surface will be porous with coarse grains. Okay, so if we have two conditions, if these two conditions are satisfied, that time only the flow rate of water will follow the Darcy's law. Okay, next topic is wastewater treatment, which is very important. Okay, so now at last, this is the last topic of this chapter. So wastewater treatment. Now in wastewater treatment we have three steps. One is primary treatment, one is secondary treatment, one is tertiary treatment. In primary treatment, generally we remove the large particles like sand particles, like clay particles, oil, okay, and also we can remove the microorganisms from this primary portion. Next, secondary treatment. Here we can remove the biodegradable waste or organic waste, and the last step, that is the tertiary treatment, that we can in tertiary treatment the remaining particles can be removed. So only in your syllabus you have the primary about the detail about the primary treatment. You don't have in detail the what are the process, what are the instruments we are using in the secondary treatment, and also the tertiary treatment. In secondary treatment, generally we use trickling filter, rotating biological contractor, and the sludge process. These three we can use, okay. And tertiary treatment, generally we use activated charcoal, because activated charcoal can absorb most of the things. That's why after all this primary and secondary treatment, the water is passing through the activated charcoal so that the remaining particle can be removed. Now we will discuss about the steps of the primary treatment. So these are the whole schematic diagram of the primary treatment. So first primary treatment, first we should do screening. Screening means what we use generally in this step. We use some of the metal bars. So through this metal bars are vertically aligned. Through this metal bars, the water is passing. So what will happen, to some extent, some of the some of the large particle will be screened through this metal bars. After that, we have the coagulation procedure. Coagulation means like coagulation means like it is applicable for the colloidal system. Colloids means while in the water we are having the sand particles, the dust particles, they are not dissolving into the water. They are making the suspensions, okay. Now what will happen if we use some of the electrolytes? What will happen, all the dust particles, the sand particles will be discharged, neutralized, they will accumulate, and they will precipitate out. This process is called coagulation. That means separation of the dust particles, unwanted particles from the water molecules. That is called by coagulation by the electrolytes. Generally we use the alum, okay. Alum means potassium sulfate, aluminum sulfate, 24H2O. So generally for the coagulation system we use the electrolytes, okay. Next we have the sedimentation. Sedimentation means after the coagulation process, they next we what we have to do, we have to just keep the water in a tank for a long time, so that all the precipitation will be settled down, okay, for complete precipitation. Next we have the sand filtration process. Sand filter, generally we use sand filter when that means there are so many layers will be there. At the bottom layer the smaller stone chips are there, and at the while you are going above, so you will get the bigger size stone chips, okay. So this is the sand filter. While the water will be passing through the sand filter, what will happen, all the precipitation will be stuck into the filter, and you will get the fresh water. Okay, so here also some of the steps we have, that is last treatment, ion exchange, black-rich water. Okay, so these are the all you can get. And after all, what we have to do, one more thing we have to do, that is a disinfection process. Disinfection process means here what will happen, first of all we have to use the chlorine, or we have to use the ozone. We have to treat the water with chlorine or ozone, so that all microorganisms like bacteria, virus can be killed by this chlorine or ozone. Okay, so this is the disinfection procedure, and this is the total whole primary treatment. Next, after the primary treatment, then we will follow the secondary and tertiary treatment for the total wastewater treatment. So this is the recapitulation, whatever we have discussed so far. That is the, we have classified the pesticides, we have defined the aquifers and hydraulic gradient, we have stated the Darcy's law. Darcy's law actually related to the flow of the flow rate of the water, and ultimately we have seen how we can treat the wastewater, and how this wastewater can be consumable. Okay, so all this checked. Yeah, all this we have covered. So thank you, students. You have to follow my classes regularly, otherwise you cannot understand the whole topic. And this is the end of the chapter. So after this we will discuss also some of the questions, that this type of questions generally you can have in your exams. Okay. And for that you have to follow my classes regularly, properly, and also you were given some of the assignments that you have to submit. Okay, thank you, students.